Hello everyone. Welcome back to the video on software engineering. And in this video, we are going to learn about a new set of topic, which is the next stage of SDLC, that is planning. And we are going to learn about various terminologies that we use in software planning. How do we do software planning? What are how do you because as a part of planning, you are supposed to calculate the development time, the effort, the cost, the number of people involved. So we will see how we are going to do that. But as of now, the first thing is how to start planning. The first thing that you should know that there are two terms, one is called as measures and another is called as matrix. Measures are the quantitative indications of the extent and amount of dimensions or dimension or size of some attribute of a product or a process, but in general it is a single data point. So if we say I have a laptop. Okay, the laptop might have a weight. The laptop might have certain length, certain breadth, certain height. Or I have an almirah. The almirah might have certain dimensions. So those dimensions are called as measures. So at the one point of time, you might have either the length, either the height, or the weight, or the breadth. Okay, so these are called measures, and the process of measuring is called measurement, right? When you are when you are doing a measure, you are measuring something. It's called as measurement. You do measurement with certain tools that you do. Likewise, when you correlate multiple measures, right, and you say that height, how many students of the height called 5 are of the weight called 50, how many students are the height called 7 can have a weight called 40. What you are doing, what you are going to do, what are you going to get out of these when you relate multiple measures together? You get a matrix. The matrix will is a set of information that tells you about various attributes. Suppose I say that people in this country in a classroom are on average height of 6 and the weight is 40 to 45. Okay, a height of 6 actually can go up to a weight called 60, but right now the average weight is coming to be 45. That means they are malnutrition, they are lacking in certain nutrition value, right? Or I can say the student or the average height is 5 and the weight is 60. That means a student of weight 5 cannot have a weight called 60, which is an obese state of weight. So I can get certain information out of it. So the degree to which the system component or a process possesses a given attribute relates several measures together is known as matrix. Now, uh, when we see why do we why to have some product matrix, because it helps software engineers to do better understand the attributes of models and access the quality of the software. Okay, now coming to the software examples. So if I want to have an understanding that how many people working under me are efficient, so this I should know how many lines of code they are writing per hour, how many defects they are finding per hour, or how many documentation page of documentation they are doing per hour. So if I can relate the time and the document, or time and the errors and time and the lines of code, then I can analyze their working, the quality of work that is a part of their work. Secondly, it helps software engineers to gain insight into the design and construction of a software. The lines of code and other aspects focuses on specific attributes of software engineering work products resulting from analysis, design, and coding and testing. And it also provides a systematic way to assess the quality based on the set of clearly defined rules. So these are the basic reasons why we go for certain set of matrices. Now, these examples of matrix that we as a human being create is cost of utilities for a month, like cost of groceries for a month, time spent on mowing the lawn for the past 2 weeks. We do these from the childhood. We create matrices, right? We actually create when we play a cricket match. and I believe most of you must have played a cricket match or any type of game, and you must have maintained a record that in one day how many runs you scored, how many wickets you take, and how many catches you caught. So this is the number of matrix that you actually creates in day-to-day life. Likewise, you can think of certain matrices which are part of our college experiences. Okay, you can pause the video, think about it, and write it down somewhere. And then this is an exercise that you should do. It will make you feel that yes, I am on the right path. So when I show the next slide, it might some of the matters may align with what you have written down. So as of now, I request pause the video, stop it, take a pen and paper, write the some matrices like the one this mentioned here for your college experiences, and then come back to this video. Okay, so we are going ahead, but I request you to stop and do this exercise and let me know how you feel after doing the exercise. So the some of the examples can be like the grade received in the last class last semester or the last semester. So you see you are in the fifth semester suppose. So you when you come for the first semester and you see okay this is my grades. So in the second semester whether the grade improves or whether it degrades, or if there are certain subjects that are related to each other. Suppose you are studying programming in the first year, then you are studying OOPS in the second year. So whether you understand, if you are getting a bad grade in OOPS, that means you have not done the programming exercise well. Or if you've done the programming exercise well, even though you are not getting a good grade in OOPS, like operating object-oriented programming, then it says that you are lacking some of the practicals or theoretical concepts. You make certain analysis of it based on the information that you receive, right? So these are some of the matrices that actually you should create while you are in the college level. And going ahead, this will help you to analyze your own performance and give you more boost in your career. So these are the examples of matrices. So matrices can be either direct or matrix can be indirect. Direct matrices are those that for which I can get the data directly, like from the system I can get the data back. Like lines of code, I can count the lines of code and find the data, right? I can measure the execution speed and I can take the data. I can read, I can find the defects reported and I can take the data. So these are called as the direct attributes, right? Immediately measurable attributes. And the second thing is called indirect measures. These measures are not directly quantifiable, right? Immediately quantifiable, like functionality, like quality, like reliability. These are gathered based on certain different other type of tasks. So when we will see quality, software quality in the third section of this software engineering, in the upcoming lectures, we'll talk about the indirect measurement as well, right? Not the matrix. We will tell you how it measures, but we won't go in deep about the matrices of indirect matrices. But rest we will tell you what are the different matrices that we will use in measuring the indirect attributes. But as of now, we are focusing on the direct attributes. Okay. So with this mindset of with the knowledge of matrices, we can now think about planning can be done with the help of matrices, and matrices do depend upon measures. Okay, so coming to software sizing topic, the software sizing topic actually tells you about how to estimate a software. Okay, how to estimate a software, and it's an activity in software engineering that tells you about that is used to determine or estimate the size of a software application or a component in order to able to implement the other software project management activities such as estimation and tracking. So you want to estimate certain thing, right? And understand the complexity with this definition that you are going to estimate something which you have not even designed, and forget about coding. You haven't designed it, but you are going to estimate. You're going to estimate the lines of code, you're going to estimate the effort, you're estimating the time, you're estimating the number of people at this stage when you don't have that thing in place. Okay, so just as the size is an inherent characteristic of a piece of a software, like a weight is for a human being or a tangible material, right? So we are more focused on the size, and everything falls primarily on the size of the software. So based on the software size, we can do that. We can estimate the size using software sizing matrices. So there are two type of software sizing matrix. One is the size orientation matrix, another is called the function point matrix. Size orientation matrix generally is a type of matrix that is used to estimate the effort and development time by calculating the lines of code. Example of such matrix is given here. Like you are having, so you can have a matrix called you can see a matrix here which can be something of this sort. It has the data about projects, right? It has the data about the lines of code. The lines of code is 12,100, 27,200, and 20,200. Then it also has something about the function point. We will discuss this in future slides, so don't bother what is function point. It is the effort that you put in. It is in person month. This is the rate that we do. That is the documentation per page. This is the number of errors. This is the number of defects. This is the number of people involved. So you have a matrix like this. Okay. Now when you, these are the historical data. So or I can find out what is the effort required. So I can find the effort required. If I want to create matrices out of it, I can create lots of matrices like errors per KLOC. So if I say the errors, so I have the error value here, right? At is error value is 134, and the KLOC is so the LOC value is 12100, right? So let us come back to the slide and try to create a sample value. Suppose the lines of code, the errors was 134. The error value was 134, and LOC value was 12100. Okay. So LOC and KLOC means KLOC is 1000 lines of code. So this will be equal to 12.1. Okay. And by default, the size orientation matrix, when we will talk about KLOC. So errors per KLOC, this is a matrix we will tell about 134 divided by 12.1. So you will get certain figure here, and that figure will tell you about errors you make per 1000 line of code. Okay, if this value is coming to be more, that means you need training, you need expert people, right? And with this you can do lots of analysis. Likewise for defects, or for the rate, for the page documentation, for errors per person month, or LOC per person month, and the rate per documentation. There are some of those matrices that can be drawn with the help of the data that's been provided to you, right? So if a data has been given to you, you can draw multiple type of data for you. Suppose you don't have the data, okay, and then also you want to do an estimation, then how you will do it? Then in that case, you have to use a formula which says that you can talk to someone which is called as pessimistic value, right, and optimistic value, and the most likely value. Okay, pessimistic and optimistic are two ends of a system. So if I say pessimistic is here and optimistic is here, right, I know what is I know everybody knows what is pessimistic and optimistic, right? So either one of people might be plus and another might be the minus, right? So if I ask someone who says that if we have done something in the recent projects, right, he might give you an most of all most likely value, right, like M. So most likely value is someone like if somebody studied a particular subject today itself, like in the last semester, and you are asking him how many hours do you spend reading in the final stages, for the final exams. He will give you, okay, I read that subject in the last week for 4 hours a day, suppose. So it means you most likely. If so, you ask someone who has studied 4 years back, he might give you a rough idea, right? So if it's a very very like studious person, he might give you an over the stage, like I'm asking you 6 hours or 8 hours a day. And who is very like careless, he can give you only 2 hours is sufficient for reading. So what you do, you take 6 hours or 8 hours of day, you also take 2 hours of a day, and you take 4 hours of a day. So now all these values are there. So what you need to do, you will take 8, you will take 2, but what you will do, you will like create a weighted average of all these. But the weight given to the pessimist is 1, the weight given to optimist is 1, the weight given to this value most likely is the largest, 4. When you divide it by 6, you will get 8 plus 16 plus 2 divided by 6. That comes out to be 10 and 16, 26 by 6. That comes out to be approximately 4 point something something, right? That means if you spend 5 hours, it is sufficient for you to learn the subject, right? So it comes close to the most likely, right? So this is the reason why we choose, when we don't have exact historical data, we will choose the option of most optimist, the pessimist, and the most likely, and we create a data with the help of this particular size. But the size should be in LOC. If it's LOC, convert it into KLOC. This KLOC value will be 1, the KLOC will be 2.5, this KLOC value will be 1.5, and then you can calculate easily, right? Now there are some drawbacks of this size orientation matrix. It says that the LOC measures are programming language dependent. That means the more lines of code you write, the more the estimation will be better, right? Because it depends upon directly upon LOCs. And secondly, it is measure is also dependent on the level of skills the programmer has. So if a programmer is more efficient, he writes the code in the less lines of code, will be penalized for that. So this is the drawback of the size orientation matrix. Now if you have these values, I request you to calculate and find the LOC value, and the LOC value will be finding in 15583. Okay, 15 LOCs. Now what this thing out, eventually I will have some historical data, and the data says average productivity of system is 620 LOC per person month, and labor rate is 8000 per month, cost of lines of code is 13. Okay, now and with the help of these data of the LOCs, the data of an LOC, right, this is the LOC value that is given to you. These are the values, this is the past historical data value. Now what you need to calculate, these two things. You need to calculate the estimated project cost, and you need to estimate the efforts in person month. So you need to convert the effort also, and you need to find the cost also, right? So for that you have this particular data available. To pause the video, note down the value of the size and the data given to you, calculate the value of the cost or the effort, and comment it out in the comment section of the video. We will be giving you the answers in the comment box whether you are right or wrong. And if you want to understand how we calculate these values, let us know. We will give a very short video explaining the actual solution of this problem as well. So as of now, this was all about size orientation matrix. We will be seeing some more about thing about function orientation matrix, how we calculate a function point, and how we actually convert function point into LOC, which is known as reconciliation of the LOC and FP, in our next video. Thank you.